So the one we just did on the board is Mg3N2. And we figured it out based on the Lewis dot structure. But the other way to do this involves looking at the periodic table and just figuring out what the charges are. And we're able to do that because ionic formulas always form neutral compounds. So the goal here is to form neutral compounds. All right, so if we took the magnesium, what would be the charge of the magnesium here? How can I figure it out? Okay, I'm looking at my periodic table. Now what? Right, it'd be positive 2 because it's got 2 valence electrons, and it's easier to lose 2 valence electrons than it is to gain 6. So we're going to lose 2 valence electrons. We lose 2 electrons. Well, electrons are negative. If you lose 2 negative charges, you become positive. So the charge on the magnesium would be 2 positive. Good? Okay. And the other element is nitrogen. Well, let's take a look at nitrogen. What's the charge on the nitrogen going to be? -3. Yeah. Because we start with 5, and it's easier to gain 3 electrons, 1, 2, 3, than it is to lose 5. So we're going to gain 3 electrons. Electrons are negative, therefore we have a -3 charge. Good? It is. All right, so we're trying to get to a neutral charge. Best way to think about it, what's the least common multiple of 2 and 3? 6. So that means I need a total of 6 positive charge and 6 negative charge, because that would show that I have a neutral compound that has 0 charge. 6 positive charge, 6 negative charge gives me 0 total charge. Good with that math? 6 minus 6 is 0?
Yeah, but how do you get 6?
So how many positive magnesiums do I need to get a total of positive 6? How many magnesiums do I need to get a total of 6 when each magnesium is 2? How much? 3. And how many nitrogens do I need when each nitrogen is -3? So if I have 3 positive 2 magnesiums, that would be a total of positive 6. And if I have 2 -3 nitrogens, that would be a total of -6.
So all you have to do is just like flip the numbers and then the symbol?
Well, kind of. Because what if we took something like calcium and silicon? What's the charge on calcium? Two. It's in the second column, right here. So we have 1, 2 valence electrons that we're getting rid of. What's the charge on silicon? -4. 1, 2, 3, 4. So, yeah. 2 ways I could look at this. I could look at this as crisscrossing them, or I could look at this as finding the least common multiple. Least common multiple would be 8. So if I had 8 and -8, how many calciums do I need?
4.
How many silicons do I need?
2.
It's 2. Okay, and I'd have Ca4Si2. Why would that not be finished, though? No? So when we're talking about ionic formulas are a ratio of atoms. And we want to be able to reduce it or simplify it to the least values that we can. So what could I reduce this ratio to? 2 to 1. Ca2Si1.
That works?
That works. But I want to clarify, that works for ionic formulas.
Just dynamic chemical.
Right. That works for ionic formulas because ionic formulas are a ratio of elements. Ionic formulas are a ratio of elements. Good? Okay. You can flip them, but you need to make sure that you then reduce them. Okay? Questions on ionic formulas and the shortcut way of figuring out what the formula is. Still, if you're not comfortable with this, the Lewis dot diagrams always work. If you like the Lewis dot diagrams, use the Lewis dot diagrams. Check your answers with them. It's a good thing to do. Okay? All right. That's topic 1 for today. Topic 2 is polyatomic ions. No? What does poly mean? Many. Many. A polygon is multiple-sided shapes. No, that's a square. Or a rhombus, or a parallelogram, or a tetrahedron. Tetrahedron. All right? So poly is many atom ions. And a polyatomic ion is just that. An ion made up of many atoms that are covalently bonded. Ions made of multiple atoms covalently bonded. So what if I took a set like Mg, N, and O? What kind of bond would these have if they were all in the same compound together? Why covalent? Because oxygen, give me a little more. Okay, oxygen's a nonmetal, and what else? And nitrogen's a nonmetal. So we could say this is covalent. Is the whole thing covalent? No. Why not? Magnesium is a metal. So since magnesium is a metal, we know there's also an ionic bond. And what we actually see is there's both an ionic and a covalent bond in this compound. So if I start with my nitrogen, 2, 3, 4, 5, and my oxygen, 1, 2, 3, 4, 5, 6, and I start bonding them, I get to here, and what do I find? I get to here, and what do I find? Say again? I filled the oxygen, but not the nitrogen. Well, instead of coming up with another oxygen, we just happen to have some spare magnesium lying around that comes in contact with it. And when it does, these rogue electrons come flying over here and join the NO. Well, now what we've got is a combination of nitrogen and oxygen that has a net negative charge. And together it has a -1 charge. Well, since this is negative, and magnesium is going to be positive once that electron leaves, this electron is also going to go join another NO group. And I'm going to have both covalent and ionic bonds. So I'm going to actually wind up with magnesium and a group of 2 NOs. So I've got my covalent bond. See the covalent bond inside the parentheses? And my ionic bond, which joins the magnesium with the piece that's in the parentheses. And you'll see, because I had 2 electrons, I wound up with 2 sets of these. Yeah? Because I took magnesium and I dropped it in a box with nitrogen and oxygen. What the chemical combination is that forms it isn't what we're interested in right now. Next chapter we'll figure out how to make the reaction happen. What matters is that we know that we can have something like this exist. Hey, guys, I need one question at a time. Eva, go ahead. Well, how many electrons did the N and O gain? 1. So how many more electrons would be here than protons. What's the charge of an electron? So if I gain an extra electron, my group should have negative charge. Good there. Hey guys, I'm only going to say each of these things once, so if you're not listening, don't be surprised if I just give you a dumb look if you ask the same question. Okay? So keep going, Eva. So we had, when we started, the number of protons and electrons were equal, right? Yep, because when we look at our periodic table, we understand that like nitrogen has 7 protons. It also has 7 electrons. Those 2 are on the first energy level, then we see these 5 valence electrons. Well, it's going to gain an extra one from some other source. In the situation we're talking about, some other source is magnesium. So since it's now gained an extra electron, this as a group is negative.
Okay, is just the N?
No, the N and the O together are negative.
Okay.
Okay? Our magnesium, because it's lost the electrons, is positive. And normally, when the magnesium loses 2 electrons, what's the magnesium's charge? You lose electrons? Positive 2. So if the magnesium loses 2 electrons, and a single group of nitrogen and oxygen gains 1 electron, the nitrogen and oxygen gain a negative 1 charge. The magnesium gains a positive 2 charge. You with me on that?
No. I'm lost. So do you bond the end of the alphabet first and then
Yes. Okay, illustration. Are you guys currently sharing the table?
Yeah.
Okay. Do you have 1 eraser per person at your table?
Yeah.
Yeah? You don't have an eraser? Do you have 1 eraser at your table per person?
Sure.
Okay. You now have 3 erasers at your table and 2 people. Do you have more erasers than you have people?
Well, I'm sure. Yeah.
You do? Okay. I'm currently absent an eraser.
Okay.
So I have lost my eraser, and they have gained an extra one.
Here.
Same thing's going on with the electrons.
Okay, that makes more sense.
So these guys as a group have a set number of electrons. As a pair, they have a set number of erasers. As an individual, magnesium gives up the extra electrons. I don't need an eraser, I'm writing a pen. So they got the electron, they got the eraser, they got the electron, because they needed that many to fill their valence shells. Okay? That means that this magnesium has lost all its electrons, and therefore is drawn towards the negative polyatomic ion because they have opposite charges.
Okay. So you just gotta do like nitrogen.
You would. You do the covalent ones first. All right. So this is a weird group. How would you know what the weird groups are? Well, so polyatomic ions. Take a look through this column of polyatomic ions, and I want you to look for any kind of patterns. What makes them identifiable? How can you tell if something is a polyatomic ion? If it has more than 2 elements, all right. What if I'm not writing out the formula? What if I'm saying the name? They end with TE. Is that all they end with? 8 or ite. Most polyatomic ions end in 8 or ite. Now, what do most compounds that have an element end in?
ID.
Right, IDE. So if it's an element, it ends in IDE. Now I want to point out this guy real quick here, because he's going to try to trick you. Hydroxide. He is not following the rules and is not playing fairly. Hydroxide is an OH polyatomic ion. It sounds like hydride or oxide, which are both hydrogen and oxygen, both on the periodic table, but hydroxide is the only polyatomic ion that you will deal with that ends in IDE. Be aware of it because it's going to trick you.
What's the first one that ends in IUN?
Ammonium?
Yep.
It's ammonia with a bonus hydrogen.
So is that one polyatomic?
It is polyatomic, but it's just the only positive one that you're going to be dealing with. All right. So, looking at polyatomic ions, most polyatomic ions end how? Ite or ate. All right. Next thing I'd like you to do. Find a pair of polyatomic ions that have similar names but are different in ite or ate. Take a look, see what's different between them. Find a pair of polyatomic ions on your sheet that end in ite and ate. And what's the difference between them?
Hypochlorite and
That are similar in name. Like sulfate and sulfite. Or is there another pair somebody found?
chlorite and chlorate.
I heard nitrate and nitrate. I heard chlorite and chlorate. Nitrate and nitrite. Ite and ate. Did I? Oh, my mistake. Maybe I made a mistake there. Okay. What's the difference between the two polyatomic ions that have a similar name?
No, it's like the smaller lower is like different by one.
So the smaller number that's modifying what?
The number.
I heard the O. Take a look. It's in every one of those. So if I'm looking at phosphite and phosphate, it's a different number of oxygen. If I'm looking at sulfite and sulfate, it's a different number of oxygen. If I'm looking at nitrite and nitrate, what do you notice? Different number of oxygen. How about chlorite and chlorate? Different number of oxygen. How are they different? They're within one of each other. Can somebody be a little more specific?
Like they're only like one over. No.
Which has more?
I mean, the eight.
Does it always?
No. Yes.
Yeah, it does.
Because she ate.
Okay. Ite always has one fewer oxygen than 8. Yeah, and that's actually why we use ite and 8, because all of the polyatomic ions with ite and 8 have oxygen in them. You'll notice that I think there are 3 on this page that do not have oxygen in them. None of them end in ite or 8. So you look up at the top, ammonium, there's no oxygen. It doesn't end in ite or 8. Hydroxide, okay, hydroxide's a weird one. It's cheating. Blame hydrogen. And thiocyanate, yep, which does not have any oxygen, but does have an 8. You want to know what's not going to exist? Thiocyanate.
Why?
Because there's no way you can reduce the number of oxygen.
Oh.
Right.
That makes sense.
All right, so we've got the idea that polyatomic ions are covalently bonded groups of atoms that have a charge as a group, right? Okay, next thing. We understand that most polyatomic ions end in ite or 8, and that ite always has one fewer oxygen than 8. Good with that? Do I need to close this? Because I've got like squirrel group over here that's just distracted by everything.
There's just like they're playing with it.
Okay, it is. All right, so next up, we want to be able to write out a chemical formula using those compounds. So just like we did MgNO2 up here, let's try another one. Let's try sodium, Na, and phosphate. First of all, what is the formula for phosphate? PO4. What is the charge of sodium? 1.
Yeah.
What's the charge of phosphate?
-3.
-3. All right. Well, how many sodiums do I need to balance out the charge of the phosphate?
2.
How many total? How many total sodiums do I need to balance out the phosphate? 3. 1 times 3 is +3. -3 times 1 is -3. So the +3 and the -3 balance. Now what did I just do to show that this is a group? All right, so parentheses in a chemical formula shows the presence of a polyatomic ion. Show the presence of a polyatomic ion. All right, let's try one more. How about calcium chlorate? What is chlorate? Say it again, Amar. ClO3. Good. What's the charge on calcium?
2.
2. Good. What's the charge on chlorate? -1. Good. How much chlorate do I need to balance the calcium?
7, 5.
Yes.
Nope.
3.
No. Oh.
That's a 3.
I thought it was.
How much chlorate do I need to balance out the calcium?
2.
2. So I have -2 and I have +2, so I have my balanced chemical formula.
Why do you write the positive sign and negative sign after the number?
You know, it's a convention that I really don't understand.
What if we don't do it like that?
I really won't care.
Okay, good.
It's a weird convention. I don't know why it exists. It just does. All right. So, what I would like you to try now is writing the formulas for a few of these on your own. Oops. Let me find. There we go. All right. Try those on your own. You should put them in your notes or on scratch paper or, I don't care, your arm. Just write them down somewhere. Do not write them on the page that I gave you because you want to be able to use that on tests, so you don't want to have extraneous writing on it. Okay? Go ahead, take some time, try to figure them out.